In this video, we will utilize segment addition, apply congruency to segments and angles, understand and complete problems related to triangle inequality. So the measure, which we could also call the length and the distance of segment AB, is written as AB. So there is no marking above the letters. If segments have the same length, they are going to be congruent. And we can write congruent with an equal sign and a tilde above it. So it's similar to a tilde over an N if you take Spanish. Remember that distance is always going to be a positive number. So no matter what direction we move, it's always going to be positive. So we're going to use that to find the following. So we want to find the length of AB. So how do we get from A to B? So if I count 1, 2, 3, 4, my length is going to be 4. From B to C, 1, 2, 3, 4, 5, 6, 7, which if we also did 8 minus 1, that would get us 7. And AC, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Notice that AC is using the two segments AB and BC. So if I add 4 plus 7, I still get the length of 11. So in segment addition, if B is between A and C, then AB plus BC equals AC. So let's use that idea to solve for X in some other problems. So in number 1, we want to solve for X and find AB. So using segment addition, these are our two smaller parts which equal our whole segment. So we would have X plus 3 plus 2X plus 5 is equal to 20. When we combine like terms, 3x plus 8 is equal to 20. 3x is equal to 12. So x is equal to 4. Then we want to find the length of AB. Well, AB is x plus 3. So we would have 4 because we're substituting our value in. So that's going to have a length of 7. Congruent segments and angles. So congruent segments are segments with the same measures. If our segments are congruent, we're not always going to have a length given to them, but we might have the same marking. So if we have these two segments A, B, and C, D, if they both have the same marking, so in this case 2 tick marks, we would say that segment AB is congruent to segment CD. The same thing with angles. Congruent angles are angles with the same measure. So in this case, I might have an angle here and an angle here. So this is A, B, C, and this angle is D, E, F. If they have the same kind of marking inside, so in this case, a double little arc, those would be congruent. So we would say angle ABC is congruent to angle DEF. Notice that B and E are in the middle of those angle names because those are the vertex. In order to know if something is congruent, you have to be told it. You can't just look at it and say, oh, they look like they're the same size. It has to tell you that somewhere. So in number 2, which segments are congruent and which angles are congruent? So if we look at the two pictures, or the 3 pictures of the triangles, we see that these segments have the same tick marks. So we could say that ZW is congruent to YX. If we look at the sides, another set of sides that is congruent, they both have the circles on them. So we could say that KH is congruent to RT. Then, if we look at our angles, Some of the angles that are congruent are these two angles. So angle W is congruent to angle X. We also have these two angles with the same marking. So we could say angle K is congruent to angle T. In number 3, given JA is congruent to CK, solve for X. What is the length of CK? Is CK congruent to IE? So right now we are just operating under knowing that these two are congruent, JA and CK. So we're going to set those equal to each other because if they are congruent, they have the same length. So we know that 5x minus 17 has to equal 3x plus 23, and we can solve for x. So we get 2x is equal to 40. So x is 20. Once we know what x is, we can substitute in. So 3 times 20 plus 23 gets us a length of 83. And then to know if CK is congruent to IE, we need to see what is the length of IE. So what is 7 times 20 minus 62? That gets us 78. So is CK congruent to IE? No. CK is not congruent to IE because the segments don't have the same length. In number 4, on PS, PQ is congruent to RS. What is the length of PS? So we were told that PQ is congruent to RS. So we can set those equal. X minus 1 equals 3x minus 7. So we get 6 is equal to 2x. So x is 3. So our lengths here, when we substitute in, 3 minus 1 is 2. X is just 3, and then 3 times 3 minus 7 is 2. PQ and RS should have the same length, so it's good that they're both 2. So to find the length of PS, we want to add those all together. So 2 plus 3 plus 2 would get us a length of 7. In number 5, solve for X. Is KM congruent to MD? So right now we don't know if they're congruent. We're trying to investigate that. So we're going to use segment addition. So we have 7x plus 15 plus 9x minus 11 is equal to 10x plus 82. When we combine like terms, 16x plus 4 is equal to 10x plus 82. So we can subtract 4 on both sides and 10x on both sides. So we get 6x is equal to 78. When we divide by 6, x is 13. So we can substitute that back in. So 7 times 13 plus 15 is 106. And 9 times 13 minus 11 is also 106. So are those congruent? Yes. KM is congruent to MD because the segments have the same length. If RS is 12, RT is 40, and ST is 28, which point is between the other two? Well, we notice that RT is the largest number at 40. We can also check that 12 plus 28 is equal to 40, which means it's going to be the length of that. So RS plus ST is equal to RT. So the point that's going to be between is the point that repeats, which is this S. So S is between R and T. In triangle inequality, so when we have triangle inequality, there's a lot of different sizes of a triangle that can make a triangle happen with the three sides. So the three segments form a triangle if and only if the sum of the two shorter sides is larger than the third side. So using this triangle inequality, we can figure out what does the third side have to be between in order for a triangle to be created. So number 7, if the two sides of the triangle are 7 and 18, what are the possible side lengths for the remaining side? So the third side is x. So if we say the two shorter sides have to be larger than the third side, we don't know if 7 and 18 are the largest side or a shortest side. So we're going to try 3 different inequalities. So 7 plus 18 has to be greater than x plus 7 has to be greater than 18, and x plus 18 has to be greater than 7. So let's solve for x in each of these. 7 plus 18 is 25. So 25 is greater than x, which means x has to be less than 25. In our next inequality, we can subtract 7, so we get x is greater than 11. And in our last inequality, 18 is already greater than 7. So this inequality is going to get ignored because if 18 is already greater than 7, we don't care what x is because it's always going to be true. So if you notice, we have something x is greater than and something x is less than. So x has to be between 11 and 25. The fastest way and the shortest way to get this is to subtract the sides to get your lowest number and to add the sides to get the highest number. So in number 8, we don't have to do all 3 inequalities. We can do it a little bit faster. We want to find the third side length. So we are going to take the two sides and subtract them. And x has to be greater than that, but x has to be less than when we add the two sides. So 18 minus 12 is 6, and 18 plus 12 is 30. So as long as x is between 6 and 30, that's going to create a triangle.